Okay, let's start it. Hello, everyone. I'm Jang Bin Jo. I'm excited to present our project result about Camp 2025. Our topic is enhancing quantum diffusion models for complex image generation. First, we start it. Before we start it, let's look at the intro. Yeah, quantum machine learning combining quantum computing and AI is a popular one, and maybe, yeah, and quantum diffusion models are generative model for data. Below figure is a diffusion process. For the diffusion process, it is adding the noise. Yeah, like a 7 digit and adding like a Gaussian noise, and it is a result. Here is a 10 step, and in the model, uh, simulating quantum enhanced generative model for complex image generation. It is our goal. And so how can we improve image quality for multi-class data set with limited qubits? We use only 4 qubits in the model and one ancillary qubits for 10 class 0 to 9 digit. And how can we design an efficient hybrid quantum classical architecture for image generation? So we research and ideation and make a prototype model and feedback and revision. Then now we can get a quite better, quite good model in quantum diffusion process. Yeah, here is our architecture. We use a quant bottleneck architecture like a quantum UNet. It is using classical encoder and decoder and only use for image abstractor for using 4 qubit. It is a quantum bottleneck part. It is a ansatz like a convolution circuit. And here expectation value, we use a decoding process combining uh, bottleneck scheme method. Scheme method. Yeah, so in classical decoder, and we can get image, result image. So in burst our model, there is some problem. In binary class, digit 0 to 01, it looks good. Look, but in multi-class, it looks bad because it seems to overlap to 0 to 9, so we can distinguish the number. So it is problem. Maybe it is come from the balance players. It is a popular problem in machine learning. So we consider how can we overcome this problem. So first, we start to measure the circuit performance. How can we circuit performance? We consider and how can we we find the entangling capacity for the circuit. It is our model description in it is in the our drive material. Maybe it can share the after the presentation, and get uh it is a optimal two-qubit decomposition we use for convolution layer. There are three parameters for optimization: alpha, beta, and gamma, and it is uh, high high feature for two-qubit fully entangled circuit. So it is a result our model. Looks good. Training is good. Performance inside looks good. And our result is final class. Oh, it is sharpening and looks good. This is how we distinguish what is zero and what is one. Look, looks good. And in multi-class image generation, the sampling result is quite bad, but this looks good because in people there's a and it is a total process or denoising process. So this looks good, and we can get zero, zero, and zero, one and one, one to one. So like this, this looks good. People, in the people one. So the conclusion is here. The proposed hybrid quantum classical model show promising result in image generation despite the challenge like a balance players. We can get effect, effective technique or applied optimization. And the model demonstrates scalability and potential for complex data set like a fashion amnist. Thank you.